Experiential learning in mathematics is a teaching approach where students learn by doing, reflecting, and applying mathematical concepts to real life situations rather than only memorizing formulas or procedures. The idea is strongly connected to educational thinkers like John Dewey and David Kolb, who emphasized that learning becomes meaningful when students actively experience and reflect on what they do. In mathematics, experiential learning means engaging students in hands-on activities, connecting math to real-world problems, encouraging exploration, discussion, and reflection, allowing students to construct understanding themselves even in a traditional classroom. With blackboard, textbook, fixed seating, teachers can implement experiential learning using structured strategies. Below are practical techniques with examples for the secondary stage activity-based learning technique. Students perform structured activities using materials or classroom objects. Examples: algebra, class 8 to 9, use matchsticks to form algebraic expressions. For example, make patterns. 1 square, saw 4 sticks, 2 squares in a row, saw 7 sticks. Students derive formula 3n p plus 1 mensuration, class 7 to 8. Measure classroom desks to calculate area and perimeter. Surface area, class 9 to 10. Make paper models of cube, cuboid, cone, and calculate surface area. Real-life problem-solving technique. Use real-life situations requiring mathematical reasoning. Examples: linear equations. Class 8. If a taxi charges Rs 50 fixed plus Rs 10 per kilom, form equation and calculate fare for 8 kilometers. Percentage. Class 7. Calculate discount during festival sale, 20% off on Rs 1500. Statistics. Class 9. Collect heights of students and find mean, median, mode. Project-based learning technique. Students complete longer tasks involving investigation and presentation. Examples: data handling project, class 9, survey 50 households about water usage, represent data using bar graphs and pie charts. Budget project, class 8-9, plan a school picnic budget using profit-loss calculations. Similarity, class 10, measure height of school building using shadow method based on similar triangles. Mathematical games technique. Use competitive or collaborative games. Examples: algebra bingo, probability using coins and dice, coordinate geometry treasure hunt, locate points on graph. Games improve engagement and conceptual clarity. Inquiry-based learning technique. Teacher poses open-ended questions. Students investigate. Examples: triangles. Class 9. Draw different triangles and measure angles. Students discover sum of angles, so 180 degree. Arithmetic progression, class 10. Observe pattern 2, 5, 8, 11. Ask how to find 20th term. Use of manipulatives technique. Use concrete objects to represent abstract ideas. Examples: algebra tiles for factorization paper folding to show symmetry, geoboard for area and perimeter string and pins for ellipse formation. Experiments in mathematics technique. Treat mathematics like a laboratory subject. Examples: verify Pythagoras theorem by cutting squares on triangle sides. Probability experiment: toss coin 50 times and record results. Verify angle properties of parallel lines using protractor. Collaborative learning technique. Students work in small groups to solve problems. Examples: group solving of quadratic equations. Peer explanation of trigonometric identities. Math debate: is 0 a natural number? Field-based learning technique. Learning outside classroom. Examples: visit market to study profit and loss. Observe architecture to identify geometric shapes. Measure playground for area estimation. Use of technology, even in traditional classroom. If minimal technology available, use spreadsheet for statistics. Show graphing using projector. Demonstrate transformations using geometry software. Reflection and discussion. Experiential learning is incomplete without reflection. Teacher should ask, what did you observe? What pattern did you notice? How did you solve the problem? Can this method be used elsewhere? Role of the teacher in experiential mathematics classroom. The teacher acts as facilitator, guide, questioner, observer, motivator. Instead of telling formulas directly, the teacher helps students discover them. Advantages: at secondary stage develops logical thinking, improves problem-solving skills, reduces math anxiety, connects mathematics with daily life, promotes deeper conceptual understanding. Conclusion: experiential learning in mathematics transforms the classroom from a teacher-centered environment to a student-centered exploratory space. Even in a traditional classroom, teachers can use activities, projects, games, inquiry, and reflection to make mathematics meaningful and engaging at the secondary stage. Experiential learning in mathematics is a teaching approach where students learn by doing